Hi students, in this video we're going to learn about the logarithm laws. Alright, so after watching this video you should be able to recall the logarithm laws and also apply them and use them to simplify logarithmic expressions. Alright, so there'll be a few things you'll have to remember in order to complete this video. So first of all, our definition of logarithms. If y equals log base a x, then a to the power of y is equal to x. So they mean the same thing. Logs are almost like the inverse operation of our exponentials. Now, the other thing that's worth remembering is our index laws. So laws like a to the m times a to the n equals a to the m plus n. Laws like that, or a to the 0 equals 1, those laws are also used to help us understand and make sense of the logarithm laws. Alright, so logarithm laws are used to simplify the logarithmic expressions. In the same sort of way that index laws help us simplify indicial or exponential, they mean the same thing, expressions. Now each logarithmic law corresponds to a matching index law. So for example, looking at our first log law, log base ax plus log base ay equals log base ax times y. Now that rule looks very similar to a to the x times a to the y. Whoops, that shouldn't be there, that should be a power. A to the y equals a to the x plus y. So we've got x times y here, and we've got x and multiplied and y here, and then log x plus log y, just like we do in our power. So in that same sort of way, addition and multiplication go together, and in our second log law, subtracting our logs means we can divide our values. Just like if we divide our indexes, so if we've got a to the x divided by a to the y, that means we get a to the x minus y. So dividing and subtraction go together, just like adding and multiplication goes together. Now this rule, log a y to the x equals x log base a y. Now what's basically happening is our power is able to move to the front of our log. So that power x is able to move to the front of our log. If you want to try and work it out and see where this rule comes from, it's very similar to our exponential, our index law, that says a to the m times n is equal to a to the m times n, based on that sort of rule. Similarly, log base a of a equals 1. Our matching index law is a to the 1 equals a. So what power of a gives us a? Well, it's just 1. And then finally, log base a of 1 is just 0. Again, remembering a to the 0, or a to the power of 0 equals 1. So each of our index laws matches up with our logarithm laws, and ideally it's meant to help us remember. So mainly, addition of logs means multiplying the values, subtraction of logs means dividing the values. When we have a power with our logs, we can take that power to the front. These last two are good to help us simplify and get some rational numbers in there. Alright, so let's use these logarithm laws to help us simplify some expressions. So we've got log base 3 4 plus log base 3 11. Well, using our first index law, because we've got addition, we can multiply our values together. So we have log base 3 44. And we've simplified our expression from two logs down to 1. All right, next one, log base 4 48, subtract log base 4 3. All right, so doing that one, it's subtraction, so we can divide our values. Log base 4 48 divided by 3, which equals log base 4 16. Now when doing these logs, make sure you always try and see if you can simplify it further. So remember that 16 equals 4 squared, so that means log base 4 of 16. What power of 4 gives us 16? Well, it's 2. So there's our final simplified solution. Log base 4 48 minus log base 4 3 actually just equals 2. All right, so now let's look at this one. This one's a little bit trickier because this time we have some coefficients involved. Now, we can't apply our first two index laws, the addition and subtraction one, because of these coefficients, these numbers in front. So what I'm going to do first is take these coefficients and use that third rule, but in reverse. So that number out the front, I'm going to take that and apply it as a power on that 10. And that 3, I'm going to take it back into our value and apply it as a power of 5. So that's going to be log base 2 of 10 squared subtract log base 2 of 5 cubed, which equals log base 2 of 100 subtract log base 2 of 125. Now I can apply my second index law. When I'm subtracting, I can write that as a fraction. So log base 2 100 over 125. Looking at that fraction, I can simplify it by dividing both by 25. 100 divided by 25 is 4. 125 divided by 25 is 5. So that is log base 2 4/5. Now, that's not a bad solution. Right? It's a good way to simplify it. Log base 2 4 over 5. We could actually simplify it further. Now, the reason I say that is because I know 4 can be written as in terms of a base 2. It's 2 squared. So if I split apart this log base 2 4, subtract log base 2 5, right? 4 is 2 squared. So that means what power of 2 gives us 4? Well, that's a 2 minus log base 2 5. Right. Now this can be considered simplified as well because we've got a constant, which is nice, and just one log term at the very back. So both of those solutions are valid, and depending on the context, one of them might be easier to work with than the other. All right, so after watching this video, students, you should be able to recall the logarithm laws, the addition, subtraction, and multiplication ones, as well as remembering log base A is 1, and log of A of 1 is 0. And then apply those index laws to simplify logarithmic expressions.